Okay, welcome everyone to the MBU Tech Talks. Today's subject will be some tips and a little bit of tricks on writing flexible libraries and CLIs in Python. There's going to be some more high intermediate to what some people would call advanced Python in this talk. So I'm going to try to break that down as best as I can. And hopefully you guys will be able to maybe see alternate ways you can write libraries and stuff like that. I did have a few alternate titles when I was coming up with this one. Things that popped in my head when Justin said that I needed to actually have a title for the talk. Some of those were how to do more work so your friends don't have to, how to submit impressive looking pull requests, and Justin, in a few weeks, you can go ahead and ignore that last alternate title.
Got it. Thanks, man.
It never happened. Okay, so we have a problem. And that problem is that many people think that writing a library with the CLI is hard. And the answer to that is no, it's not. It's not really hard. But the real answer is that it actually is. Especially if you want to do something non-trivial with your library. Of course, if you just have a basic library where you're just calculating a value and returning it, that's fine. Really, that could have just been a method, but you decided to make a library anyway. More power to you. Libraries are cool. But really, the best part about writing libraries and CLIs, exactly lie. No, but actually, yes. But really, my favorite part about writing libraries and stuff in Python is that it's really fun. And since it's typically you're trying to solve some type of novel issue, there are really great opportunities to experiment with new ways to solve problems. And since it's typically something that you can control, you can enforce always being on the latest version of Python or whatever your language is of choice, so you can use all the new latest tricks and everything else that comes out. Yes, that is the only transition slide in that presentation. I'm typically not a fan of them, but I thought, heck, why not? It's a little bit extra fancy. The rest will just be quick transitions like that. So before we get started on the actual code of it, first I'm going to talk about the library where you're going to be seeing where this code is actually implemented. And that is Broker. So Broker's job is to be an infrastructure middleman, meaning that a user would use Broker to request resources, say from our sat lab, whether that be VMs from Rev or OpenShift, or sorry, OpenStack, one of those opens. And its main goal is to abstract away most of the implementation details, providing an easy, consistent interface for users to obtain and manage infrastructure resources. One of my initial goals coming out of this was to make it super simple for users to just on a daily basis get what they need, not have to really care about all the little intricacies of the entire process, and also to make that same kind of easy interface available in the library version of it. So in the middle section of this page, we have a broker checkout. Checkout meaning that I want to get some kind of resource back. And then we'll see Nick rel 7. We'll talk more about Nick's a little bit later. And then from there, it does all the things you would expect a library to do for abstracting away details, like how to connect to Ansible Tower, exactly which endpoints it should be hitting, all the stuff when it comes to processing the output and maybe chaining different actions, and just gives a little bit of more information on the info level to let it know kind of what it's doing at the high level. And then finally, the output is the DHCP address of the host that was requested. On the bottom is how you would actually use Broker as a fixture, or how to write a fixture using Broker within automation. And you can see that it's pretty similar to what you would do on the CLI. specifically the arguments that you pass into the VM broker class, are exactly the same as you would pass into the CLI as well. So once someone has a concept of passing in workflows or passing in NICs to broker, they can do the exact same thing and get the exact same result back when you're using it as a library as well. The context manager by default will do a checkout. I say by default, there is no alternative. So the context manager will perform a checkout when you enter it. And then when you exit the context manager, it will automatically check that host back in, meaning give it back to whatever resource it has. In this case, it will ultimately execute a workflow for removing the VM from, say, Rev or OpenStack. It also wraps the host in a neat little host class object, which handles things like, basic interactions, so SSH and stuff like that. All that's kind of abstracted away from the user, so it doesn't have to worry about those implementation details, and you can effectively have 2 lines to request a resource, do something, give it to the user, and then after that, it checks everything back in. So I wanted to have something that's really simple to use on the CLI as well as on the library level. So that's the goal coming into this. And how does this Parker do this? The answer, or the short answer, is abstraction. The longer answer is a lot of abstraction and a lot of, I wouldn't say a lot of code on the back end, but a decent amount of kind of tricks that are all kind of put together to make it seem like it's not doing much, but it's actually doing quite a bit on the back end of it. I don't think Brian is here, but one thing I tell him is that broker is really dumb, because it'll just pass along things that you give into it. It doesn't really do much, but the actual answer is that broker does a few smart things to appear dumb. Okay, so let's get a little bit more specific about abstraction. There's 2 main goals for abstraction with a library like this. You want to abstract away implementation details from the user. So these are things like communication between your tool and what the user wants. In this case, speaking to a provider like Ansible Tower, the user doesn't have to worry about that. It doesn't have to worry about how you actually hit the API and do authentication and all that other stuff. It can also handle common requirements without input. So this can be done by a combination of config files, things like that. And this is really essential to creating a tool that people actually want to use. If people had to pass in 15 to 20 arguments to supply all the information that broker needed to check out a host, they're probably not going to use that. They're probably just going to figure out how to use the Ansible Tower UI to request a host. Also, we have an additional goal of abstracting away programming tasks for contributors. So with this, we want to provide a baseline of functionality to build on top of. We'll get more into these later. And also offer easy ways to extend the functionality. You want to make it as easy as possible for people to contribute new features, or in broker's case, new providers to the library as a whole. So how can we make life easier for the user? The first one on the left, we'll talk about flexible configs. So we see a section of broker's config relating to Ansible Tower. Ansible Tower is what's called a provider. Now, broker has another concept under providers called instances. So these can either be different Ansible Tower hosts, or they can just be a combination of different configuration settings. So in here, we see I have what are our production Ansible towers. So we have, infra Ansible Tower or whatever, and it has a couple different things going on here. So of course, username, password, that's all expected. But we have a difference between the two where Rev is using the default inventory for Ansible Tower as a whole. It's also the default instance. And then OSP is specifying a different inventory. These are basically what could be arguments that are passed into Broker as well, except for the username password. So by default, you don't have to pass in a particular instance. It'll just read it from your config, but you could also pass it in at the command line as well. So the real goal for this we'll explain a little bit later. For shortcuts, I kind of briefly talked about this earlier. We have nicks. Nicks are effectively a way to specify arguments that you would commonly pass in. And then this third one that I have on this page is what I call reduced buttons, and we'll be talking quite a bit more about that a bit later on. So let's talk about flexible configs and how Broker does it. Okay, so we see a command on the right-hand side. I try to fit as much on the page as possible, so formatting probably isn't amazing. It's performing a Broker checkout and specifying that the Ansible tower it should use, or the instance it should use, would be OSP. This maps directly to this instance in the middle, OSP. So what that does is it injects the config settings that are under that OSP heading under the main Ansible tower provider. So it'll effectively read the base URL, username, password, and inventory the same as it does things like release workflow or extend workflow. It'll just be Ansible tower dot base URL dot username on the internal library instead of Ansible tower instances, find the index of that, get OSP, and then that. The way that we do this is actually shown on the right-hand side of the screen. So I said I was going to talk about code, and we're absolutely going to start talking about code. Here we go. And if you guys have any questions or if I'm going too fast, let me know. The point of this is so you guys understand what's going on, not just for me to ramble. All right, so at the top of that, we have the section name. So the section name will relate to basically which instance name you're trying to get, or the actual the section name of the overall settings object, which would be the provider. So we can get that by looking at self under class under name. So this will get us the actual name of the class. This is important because these are actually defined in the base provider class. So this doesn't need to be defined on each provider class itself, because it'll inherit this functionality from the base provider class, which is why we use something generic like self.dunder_class.dunder_name. Otherwise, people might think, why don't you just say Ansible Tower since this is the Ansible Tower provider? Well, we don't have to, because our other goal is to abstract away this detail from contributors. They don't need to worry about this at all. Okay, so from there, we are using Dynaconf, which Dynaconf has a way to get fresh settings from a particular section, which is what we're executing on line 32. So we get, the full level of settings from there. And then from there, we can go through a list of potential candidates, meaning the candidates would be, in this case, Rev, OSP, and testing, because those will live under that main, instances section. And then compare those names to the one that may have been passed in. In this case, we're looking for OSP. On line 39, just in case one wasn't passed in, we can look to see if a default was listed, and we see that we do have Rev as the default instance in this case. So we can just store that for the time being. But if it does find that OSP instance in there, then it'll store that. On line 44 is where we actually inject those lower level values into the higher level provider section for the settings. So that's where Ansible Tower instances rev base URL becomes just Ansible Tower base URL. Unfortunately, there were a couple things when it came to how Dynaconf does loading, but those have been resolved in Dynaconf 3.2, which isn't out yet, but once it is out, we can effectively just execute loaders for a specific type of loader. Until then, there's a little bit of ugly code here, which is calling execute loaders. It's a bit more Dynaconf specific and it's not really under the scope of this talk. Just know that there's an easy way to kind of execute those loaders further down the road. Basically, once Bruno decides to release 3.2. Okay, so that's one way you could do flexible configs. And some things to keep in mind about the generality of something when you're making a base class. All right, so shortcuts. For shortcuts, we're going to talk more about nicks. So we have a few different nicks here. rel 7, you see it being used in a checkout up here. So when you call a nick like rel 7, it's effectively the same as you calling broker checkout, -- workflow, passing in deploy base rel, -- rel version, passing in 7.9. You can basically bundle as many arguments as you want for broker under a single nick. And the nice thing about this is you can also specify additional arguments on top of that nick. But really the point of this is I'm relatively lazy when it comes to typing things in, and I want to make it as short as possible. So if I don't have to specify a bunch of arguments that I'm going to use consistently, I can just write a nick and just pass in the name of that nick. And the way that we do this is mainly through the init of the VM broker object itself. So it's going to go through the keyword arguments that were passed into it and see if nick is in there. From there, it's going to pop out the values of the nick, or the particular value of the nick, this case rel 7. Then it's going to do something where it calls its resolve nick helper method, which is basically just going to go through the settings and get the list of nicks. And really simply, if the nick is in the nicknames, then it's going to bring that value out as a dictionary, which then we can use to merge the current keyword arguments and that dictionary together. So it'll effectively think after that point that those arguments were passed in as normal arguments. That's where we're bringing kind of setting values into just live values that were passed in via the CLI. This one's a little bit more straightforward, but remember that if you guys do have questions about how something works, feel free to speak up. Okay, so before I talked about reducing buttons, this is actually really important when it comes to usability. So your tool doesn't have to do everything. And if you do want it to do everything, you probably shouldn't make that immediately present when you're presenting an interface to a user, whether that be through the CLI or maybe even if you're going to make a UI for it. This is kind of a complaint that a good amount of our customers have as well, and something that if you've been in management QE for a while, or just a QE organization for more than a few years, you've probably heard people talk about the cockpit problem, where you look at a cockpit in an airplane, there's a ton of buttons, you immediately kind of get lost, you don't know what to do. So The goal for this is to only advertise what's important, but also allow for more advanced usage in this. So broker doesn't expose all the potential arguments that you can pass in for something. What I mean by this is there are some things you can pass into broker that it processes under the hood, but it won't actually show that on the CLI. It's documented to an extent in something like a README or whatever, but these are more for advanced users and not really people that are starting to look at the tool and try to figure out how to do, the basics of what they want. Okay, so now we're going to talk about how to make things easier for contributors, how to do abstraction tasks to provide flexibility for contributors, or just make it generally easier for them to get into actually writing a new provider in this case. And one good way to do that is to use base classes. So base classes definitely are a big step in setting expectations for a contributor. They can look at it. So we see on the left, it has explanations for what each field does, as well as provide them at the class level, because this is actually important for the implementation of these particular options. And then on the right, we also have another kind of important pattern, which is basically having methods that should exist or should be implemented on something that subclasses this base provider. And if not, then it's going to go ahead and raise an exception if a user tries to call that. So if someone's creating a new provider and they starting to flesh some things out, want to try it on the CLI and try to call a command, it'll raise that exception and let them know that, hey, you still have something to take care of here. Otherwise, if you're not doing that at the base class, then they may think that they've created all the functionality that they need, but actually don't. This is something I could talk about here as well. It's not something that is immediately or may not be a pattern that you've potentially seen before, but the way that broker raises exceptions differs whether it's running in a CLI or if it's running as a library. So by default, as a library, it'll raise the exception as normal. The base exception class handles logging the exception as well as raising a particular exit code. So from a CLI standpoint, it'll raise a particular exception class. Those are also added as attributes of the VM broker class. So users don't have to import particular exceptions from broker. They can just say VM broker dot whatever exception as part of their try except. But when you're running from the CLI, it doesn't raise an actual exception that stops the process from that. It catches all of those exceptions. It'll let them log it appropriately and then raise the exit code that's part of that exception class. So users of the CLI should never see a traceback coming from broker CLI. They'll just say appropriate error messages, and then it'll exit cleanly. At least that's the current behavior. I'm sure someone can feel free to try to break it as much as possible if you guys want to. That's kind of what we do anyway. Okay, so a lot more code on this page. Base classes should also provide common functionality. So this is an example of the way broker allows providers to define validators, meaning Dynaconf validators for settings. If you guys aren't familiar with Dynaconf, I know I've talked about it a bit. I think it's a really good library for doing configuration. And one of the things that Dynaconf provides is settings validators. So the reason that we have it defined this way is that people don't have to go looking all over the place where to define their settings validators. They can just define it within their provider class itself. And then from there, the base class functionality on the right side of the screen handles everything that's needed to inject those validators into the settings object, and then does what's known as selective validation on those. Selective validation is actually a feature that's coming in 3.2 as well, but it's not out yet. So the way that it does this, validators or underscore validators is a class level attribute, so you don't have to create an instance of it, which is important. But we go through the thing that we talked about earlier with using that particular section name, but further down in the part here is where we basically remove all of the old validators or the current validators from the settings object, inject the new ones, which are on the left here, perform validation, and if that's all good, then we put those old validators back in. So we have at the end of this a complete list of valid validators that have all been validated. Let's look at this. So let me see if there's anything kind of important or interesting as part of this code-wise. Okay, it might be a little bit small, but at the bottom right-hand side of the screen is where we do that validator swap. So we say current validators is equal to a copy of settings.validators. The way that you know it's a copy is because we're using the slice annotation for Python lists, basically just a single colon inside those two brackets. So it'll copy the validators, then it will call clear on the validators list, then it'll extend that list with the validators that are defined under self.validators, which is on the left there. Then we're going to try to validate it. If we get an exception, then we raise in a configuration error. Otherwise, we're going to extend the current validators list or the validators list with what was previously in there. And the way that this looks on the contributor side, yeah, Ruta, just a second. And the way that this looks on the contributor side for when you're, implementing a provider is on this bottom section here. So instead of a contributor having to, write all this code on the right, they just call self._validate settings, passing in a particular instance name. That's it. So it's effectively one additional line of code that they need to write to actually add in their validators and do the validation. Okay. So yeah, Jiten just cracked. Validators effectively validate settings. So the way that a validator works, and this is a little bit of an aside, is you call a particular section of your settings object. In this case, for the validators, we see Ansible tower.release workflow, where release flow is a setting under Ansible tower. And you can set either defaults, you can make sure that it's a particular type, you can make sure that particular settings exist. So having the base URL is really important to talking to Ansible tower. So we're going to make sure that that exists. Otherwise, it's going to raise a validation error. There's a bunch of different patterns you can do with validation. Like here we have Mike Shriver added the ability for us to do both username and password authentication as well as token-based authentication. And this is done by basically like an OR type validation. So you must have these or you must have these, which is the token. So there's a lot when it comes to validators. But I believe that Bruno gave a tech talk on DynaConf in general last year or so. But if you have any questions about Dynaconf, you can always hit me up, and I'm more than happy to answer some questions. Cool. Okay. So dynamic CLI options defined by a plugin, or in this case, defined by an additional provider. There's a lot of different pieces here, and this is kind of the reason why I decided to do slides instead of going through the code base itself, is because there's a bunch of different pieces in different locations, and it'd be a lot of scrolling and file switching. So basically what this is you can also define, just like you did with validators, you can define the options that are going to be presented on the CLI for your feature within the provider class that you're creating. So on the left here, we see that we have checkout options and execute options. You may remember that checkout is one of the subcommands for a broker. Well, execute is another subcommand as well. So in here, we define that we want to have tower inventory as an option, as well as workflow as an option. And Dynaconf, not Dynaconf, now I'm on Dynaconf, and broker uses click as its CLI. So are you guys moderately familiar with click, or do we have people that are completely new to click when it comes to Python? This is where I'm looking for responses. Okay, Thomas Scheiss, new. Rita's familiar. I think we're going to have like a mixed audience. So basically the way that click lets you build a CLI and define things like arguments and options and all the baseline of functionality is to use decorators on top of command. And you can see a little bit of that in this kind of center picture here, where we have our checkout method. This is actually what's going to be run when you run broker checkout. Here we have a couple of decorators above it, and these are click decorators. For those that are not really completely solid on decorators, effectively a decorator is just a function that accepts another function. From there, it can do basically anything it wants with it, whether it just wants to, change some attributes of that main function, or, completely modify that main function or return something else. You can do that. But yeah, basically click works by using decorators. So what we can do with that is, knowing how decorators work within Python, we can kind of exploit that behavior to create dynamic additions to that main decorator that click is using. So in here, we're defining click options on the left. Each click option is a decorator. So that's going to return, a decorator function. And then what we can do from there is defined on the almost kind of the top right, but the second picture down, the provider options method. We can use some other Python tricks to, within just a few lines, get all the options that are defined under each provider, and then add that to the CLI if that attribute isn't set to hidden, which you see shown up at the top there. And we do this by importing the main provider class. And then Python allows you to pull a list of subclasses that are basically within scope at that time from a base class. From there, we have the kind of the subclass objects themselves, as in the class objects. So they're not actually instances, but we can hit those class level attributes on there. So we can check to see if hidden was set to true or set to false. If hidden is set to true, it's not going to add any of those commands on. It's just going to move on. Okay, from there, we're going to go through each of the options that are defined, and then even more Python tricks here. So we're going to use get attribute on the provider to form, well, to get a, basically the part on the left here. So checkout options and stuff like that. And the way we know it'll be checkout options as opposed to execute options is by, again, using more Python tricks. So a decorator, as you'll recall, takes a function or a method in as an argument. Well, Python makes it easy to get some attributes by that because, as everyone says, technically everything in Python is an object. I think there's probably some exceptions in there, but nothing off the top of my head. So this function object, which is checkout in this case, has a name, which is, as you may expect, checkout. So we can form a string in here for our get attribute access, which would then become underscore checkout underscore options, which corresponds to this underscore checkout underscore options that's defined within, say, our Ansible Tower provider. So that's how we basically get all the different options that are under that. And then using the alternate or the non-syntactic sugar method of calling a decorator, we can call the decorator function on that base command that was passed in, and then store that as command. So this way, we're chaining decorators that were defined in a different location, just like you would as if you were to manually write down each of the decorators within this commands file on top of this checkout command. So this has like two main benefits. One, it allows us to keep that our commands file a bit smaller because as more and more providers are added or more functionality is added to each provider, we don't have just a long list of decorators above each subcommand. And then we can also have people define those things within the provider class so they don't need to find where the command file is located to actually add their subcommands in. And if at any point they want to turn off their CLI options, they can just set their attribute on their class to hidden equals true. And then all of their subcommands or all their subcommand options will no longer exist within the CLI. This is something that I think I want to experiment with a little bit more, is combining the selective validation functionality with having this CLI option functionality setting basically hidden to true or something. So say, for example, your Ansible Tower provider is configured properly, then it could potentially hide those CLI options for Ansible Tower. So when we have a bunch of different providers for broker, if someone isn't going to use Ansible Tower and say they're going to use a container provider or something like that, they can just leave the Ansible Tower settings blank or just not have them in the file together. And then we won't see options for an Ansible Tower provider. This way they don't have to modify broker's code to set hidden equals true on there. They just won't see it because they're not going to use it. Okay. So let's go with some more stuff. So we have in here some fully dynamic subcommands. And we see an example of this on the bottom left. So the command that people can use to get some information about a particular provider would be broker providers, whatever the provider name is, and then they can either run help and get the output we see on the bottom left there, or they can run one of those particular options in there to get more information about a provider. So these are not defined at all within the commands section or the commands file. Like, you'll never find a broker provider's Ansible tower subcommand chain defined explicitly. This is all done dynamically. And this is done a couple of ways. So on the right here, we have the populate providers method. This is the code in the command, the commands.py file that does all the work for this. So for each provider that's there, it's going to generate the appropriate output. Okay, so this comes more into, again, remembering that click operates on decorators, and decorators are simply just functions that accept another function and chooses what to do from there. In this case, remember that when click decorates a function or a method, it's going to add its information to it and then return that method back. So just like we did with the decorator chaining in the previous example, we can do the same thing here. And that's basically all that this is doing, is it's going through the providers that are defined within the VM broker file on the left here. So we have Ansible Tower mapping to the Ansible Tower class, and any test provider mapping to the test provider class. We then have a list of provider actions, which are things like workflow, job templates, test action, etc. And each of these maps to either a particular method in that instance or nothing at all, because it's going to be handled somewhere else. So on the right, we'll start kind of on this initial for line. So it's going to go through the provider and the provider class for each of the items within that provider's method. So we have the name of it and then the object itself. And then we're doing a trick here where we are mocking the creation of a click command in here, which is the provider command that's not actually going to be shown within there. It's just going to be, well, you're not going to see provider command. You're basically just going to see something like Ansible Tower. So we create a new group or a new click group, which then becomes a subcommand, the name of which would be the name of the provider, Ansible Tower, which is what we see down here in the CLI. And then for each of those, we're going to run a particular command from there. So the old version of this was nick help, so it creates an instance of broker running nick help for that provider. So that's kind of the base functionality of that command. Now from that, we want to add additional information onto that. So additional options. So from here, we're going to iterate through the provider actions. So we have this provider actions global that comes from VM broker. We have the action name, and then kind of the provider info from there. We do a little check here to see that, yes, the provider info at this position, I'm not sure if you guys can see my mouse throughout this entire thing, is Ansible Tower, which is actually the class that we're going through right now. So we're making sure that when we're under Ansible Tower, we're not pulling information for test provider. Okay, so from there, we do a little bit of check. This was contributed by Cole Higgins to handle kind of plurals when it comes to Y and IES. Otherwise, we just throw an S on it. There's a little bit of distinction that broker has for basically listing something or listing all the available workflows compared to getting information about a particular one. You guys don't need to care about that too much. From here, we start to make some more click options. So we have, here we see a click option -- the plural version is flag get available. which we see on the left here, dash workflows, get available workflows. So we're using a combination of what we know about decorators as well as string manipulation to form human readable output in a way that we don't actually have to write all this stuff ourselves. It just kind of iterates through everything and dynamically generates it. A lot of this is, relatively, I wouldn't say simple Python. Let's say kind of basic intermediate type Python. Once you actually get into the meat of it, it's just, using f strings to actually inject values into help text, and then using our knowledge of decorators, which I'd consider more the intermediate, potentially intermediate advanced type Python, but ultimately decorators are really simple. And if you guys have questions or want to learn more about decorators, let me know, because I think they're really cool. Yeah, from there, we use the decorator syntax as we have in the past to modify that main provider command, effectively injecting all these options on top of it, like click would typically do. So that's quite a bit. But that's how you can make fully dynamic subcommands, leveraging what you know about decorators in Python, accessing attributes that are already defined elsewhere in the code, and then basic string manipulation and things like that. So it's not too tricky when you get into the meat of it. It just might take a few minutes to actually process exactly what's going on here. Okay. So that was a lot. So I wanted to leave a good amount of time for questions. We've got not as much as I would like. So please go ahead and ask questions. I've got some basic contact information on the bottom right, and of course, an obligatory dog picture as well. So now the rest of the talk is up to you guys. Stephen, no, it's not. But it does incorporate a number of things that I've been wanting to do with libraries. So that's why Broker's kind of my favorite pet project at the moment, is I get to incorporate a lot of those what ifs, or how would I do things better this time around type scenarios. Like I said, I really like writing libraries. And this kind of shows a little bit why, because you get to really experiment with some cool things and kind of show off some of those weird little quirks that you may have learned throughout the years. Things like, how objects in Python can be manipulated, or how you can access kind of dunder attributes or secret attributes of particular objects within Python, exploiting knowledge of exactly what a decorator is and how you can chain decorators without the syntactic sugar notation. You talked about tricks. How did you learn about those? Where did you take the inspiration from? A lot of this just comes from years of using Stack Overflow to figure out how things work. But no, it's kind of an accumulation, and the more you learn about kind of the underlying details of how Python works, then you'll kind of get a better understanding of how each piece can kind of come together. From there, it's largely kind of creativity and just general problem solving. Bruda asked, in what moment of Broker project life do you decide to go through this dynamic approach with Dynaconf and Click? You can just do static decorations with Click, right? Yeah, so Dynaconf and Click were immediate decisions for this library. I knew I wanted to use both of them, but the dynamic nature grew after the project was already established. So when I started considering what I would do when it comes to multiple providers with Broker, and seeing how, each time I wanted to add a feature, it would be another decorator in that commands file. It's over time, it's just going to grow kind of ridiculously. So I started thinking about ways that I can build on top of all those current decorators and inject things in that way. But yeah, the biggest motivation is I like to experiment with things, and I think it's a cool way to do it. It keeps things exciting. Actually, I'm going to stop recording now in case anyone's afraid to ask questions while they're being recorded. So for people that are watching the recording, thanks for watching this far. I appreciate it.